Welcome back. See this. This we have covered. That is inverter we have covered, NAND gate we have covered. Let us do today in this recording NOR gate. And if possible, we will finish this half adder also. So NOR gate, to do this NOR gate, so what I have said, first we have to know this NOR gate Boolean expression. So what is NOR gate Boolean expression? Y equal to A plus B bar, right? So in the previous recording, I already told that you have to start with there are two sections. One is the pull-up section. This is, let's say, pull-up. And there is a pull-down section. So we always have to start with this pull-down section. And then take the dual of the expression. Dual of expression. And go for pull-up section. So in pull-up, we will be having PMOS dividers. In pull-down section, we will be having NMOS dividers. And then their gates will be connected to give the input. And here, the section which is dividing pull-up and pull-down, that is connected here. That is, this part is called demarcation. So here you are going to take your output. So this dual of expression means do not consider this bar. Under bar, whatever the expression is there, out that dual you have to take. So that's how CMOS circuit is designed. And of course, you have to follow if dot is there, then series, you have to connect the devices, you have to connect in series. If plus is there, then you have to connect in parallel. To see the previous recording, in that I have discussed the same. More elaborately there, I have discussed. So now, if you follow this one, and you have to start with pull up means, if you see this expression, you have the plus here. Plus means you have to connect the devices in parallel. In parallel, you have to connect. In parallel, so what devices you will connect in parallel? You will be connecting NMOS because in pull down, all NMOS devices will be there. So you have this A plus B. This is the expression. And you have to, under bar I'm talking, under bar this you have A plus B. So pull down devices, one NMOS here, just because of plus parallel, in parallel I have to connect. This is our NMOS. Connect them in parallel. So we have connected. And this is our A. This is our B. Now, what is that we have to do? We have to take the dual of this A plus B. So that is A dot B. Now the dot convention has come. If dot has come, then we have to connect devices in series. So, and pull up, in pull up, we will be having PMOS devices. So, like this, one, another two. And here PMOS will have this bubble here at the gate. So we have connected them in series. And now here your A and your B. Now this pull-up section needs to be connected with the pull-down section. Here we are connecting. Where we are connecting this pull-up with the pull-down, there where we have to take the output. This is your Y. And the pull-up section will go to the VDD. So this is VDD. And the pull-down section will be connected to ground. Okay. Now, since this PMOS is a four-terminal device, here you have the bulk. So this bulk needs to be connected to the source of the device. We are connecting the source. Same way in NMOS also, we have to connect it to the source. So here source, fourth terminal, we have connected to the source. So that completes our NOR gate design. So let us do this one in LTSpice. So here you have your LTSpice. Just double click that. After that, you click this icon or go to file the new schematic. New schematic. You have got a same icon here. See. So click here. Now, according to this, we need to this device, NMOS device. Okay. So let us do NMOS device. So we have to connect them in parallel. That's why side by side I am keeping. Now two PMOS devices are required. In series we have to connect. So now I'll take this wire, connect this to the MOS first. How to use wire? I have covered that one in previous recordings. So kindly watch those previous recordings if you have any issue with the wire. How to use the wire. This extension I'm taking here and leaving. Just click left click, take hover the mouse, then left click, right click. So this separation also I'm connecting this PMOS devices with NMOS devices here. Pull up section with the pull down section here. This is that section. Now this PMOS bulk is connected to the source. This PMOS bulk also connected to the source here. Same here, the NMOS bulk is taken and connected to the source here. It's also taken and connected to the source. And from this demarcation, I'm just taking the extension and left click and then right click. Now to A, B. So I will take this label net. Here, one is A. I'll place it first, then I will edit. So this is B. This one is B. Okay. So now I need three sources. One is for A, one is for B, one is for VDD. One is this ground is there. Let me put a ground first here. So let's go to this component section, take the voltage, click OK. So one for A, one for B, and one for VDD. So take label net VDD, connect here VDD. And here extension, you better take the extension. We can place this one. Sometimes it will not be working, so better you extend this wire like this. So now go to this label net VDD. So place it here. I will place this VDD here. Later I will edit to A and B. So now this is A. This one is B. Here Y I will place. Y also required output. Yeah. So now if you see, I have covered this one completely. This AB pull down section and PMOS with the pull up section. Okay, so our NOR gate design is ready now. So what we have to do is here ground required to be connected. So just place the ground here as well, here as well. Now we have to save this file. To save file, save as. In one folder, you have to place all these designs. On desktop, see how I have done. Similar way, you please follow. On desktop, I already have created my lab demos. You also keep some folder somewhere, okay? So this lab demos folder I'm opening. Here, what I'm going to do, I'm going to create one folder. So what is that folder name? NORGate, right? So NORGate. Select that folder, open it. Now name it this. It is by default draft. It will be like draft 1, draft 2, like that. So but we have to name it properly. So this is NOR gate. So I have named it NOR gate without spaces. Okay. Then click save. So that's how you have to save the design. Now what you have to do, you have to go for simulation. So, but before going for the simulation, we have to give the values here. We had to give the values here. We did not give the values. For VDD, click this, see the mouse cursor. Now the shape is this. The moment you take here, the shape be changed here like this, the way you are seeing. Click there. So you have to right click there, not left click, right click. There you give the 5, that is 5 volts. Now here also same right click, go to advanced, take the pulse here, give the 5 volts, and T on is 10 nanoseconds, and the T period is 20 nanoseconds. This I discussed in my previous recordings, why I am giving here 10 and 20. Kindly watch NAND gate, you will understand, okay? So now this one, you can move this one here if you feel like this is like confusing. You just click this move, click over this, and move where you want this. And then for the B, right click, go to advanced, go to pulse, again 5 volts here. And this is 5 nanoseconds, and this is 10 nanoseconds. So now again click on save. Now click on run. So by default, it will be taking you on to the transient analysis. Here, give 100 nanoseconds and click OK. So now you can keep side by side here. This way tile vertically like this. Let me close this. Okay. So now what is that we wanted to print here? We wanted to print A and we wanted to print B. See the mouse cursor, how it is here, the shape. this shape is for voltage. If you see this shape, it is for current. We want voltage, not the current. So here like this, click on this, then click on this one. So three, you can maximize this here by clicking this center one here. See this one. Now we want to separate A, B. Okay. So right click, add plot pane. One more right click, add plot pane. Take this VA. See how I'm taking mouse cursor shape, change it here this way. I'm clicking left click, holding it and dragging here. Similarly for B also. So now if you click here, a cursor will come like this. Now you can take this cursor here and see that your A is 1 here, your B is 1. When both are 1, what is expected is actually OR gate 1 is expected, but this is NOR gate, it is 0. So we are getting the output. 0 it is. Now you take this cursor again here, where you see this is still 1 and this is 0. 1, 0. What is expected of the OR gate? 1. But this is NOR gate, so we are getting 0. That is correct. Now take this here. This is 0, 1 combination. Again, we are expecting 1. But since it is NOR gate, we are getting 0. That is correct. Now take this one here, where both are 0, 0. So when both are 0, 0, OR gate we are expecting 0. But this is NOR gate, so it is 1. So output is correct. This way you have to explain your output in the external exam. Please remember. Okay. So pause this video, rewind this one, go back a little bit in timestamp and watch this again, how I'm explaining. So you will gain the confidence. Okay. And to stop this simulation, what you have to do is don't close this complete application here, this one with this by clicking on this. Click low here under this big cross, there is a small cross as well. So close this one. So that way you are actually closing the simulation, but you are still there in the application open here, this LTSpice. Okay. So that completes our NOR gate. I will stop this recording here.